Live from the University of Texas at Austin, the Liberal Arts Development Studios present Essentials of AI for Life and Society. And now, here are your professors, Joydeep Biswas, Don Fussell, and Peter Stone.
Hi, I'm Peter Stone, professor of computer science, and I'm along here with the other professors of this class. And welcome to the first class session of Essentials of AI for Life and Society. This is a new course. It was the brainchild of the Dean of the College of Natural Sciences, David Vandenbout, just a couple months ago, said, let's have a course on literacy, AI literacy that's open for the whole campus. And so that's what this course is. We put it together relatively quickly, but we're really excited about the result. And the goal here is for all of you to learn about the types of AI and their applications, the risks and benefits of various AI technologies, societal impacts, and how to tell AI science from science fiction. And there's no programming requirement, there's no prerequisites. We just need you to come ready to learn. And our goal is at the end of this course that you will know what artificial intelligence is, what the terminology means, and be able to separate what you see in the movies from what's the reality. There's many auditors here, but for those of you who are registered for the class, the undergraduates, there is grading. But we see this as sort of a necessary evil in some sense. This is not going to be a course where you should be focused on your grade. As long as you do the assignments, they're essentially completion grades. It's not going to be a problem grade-wise. The assignments are to complete the assigned readings prior to class. We'll check that through answers to polls during the class. You need to be present at the lecture in real time and answer all Instapoll questions. We'll have some examples of those today. That'll also indicate that you're here. And then there's just a written reflection that you need to submit by Monday following class, which is your reflection on the reading and the lecture, just a way to sort of consolidate your thoughts. And we encourage people auditing to do those as well. The details are all in the syllabus. So just an example of the Instapoll questions. The first one here is really just check that you're present, right? There is no wrong answer here, and you're actually just indicating that you're present. So click the button to say that you are. More typically, we'll ask some questions that have no wrong answers, like the second one. So this one you can, we're actually looking for what you believe. Take a second to read it. Okay, and so again, part of the role of this is to get your thoughts. Part of it is to indicate that you're present at lecture. There will also be some questions that test that you check the assigned reading and that you're paying attention during lecture, and we'll have examples of those as today's session goes on. We have a fantastic lineup. The course will mainly be guest lectures from the university's experts on the particular topics that we have. And we have basically the first 2/3 of the course is on computer science topics, but for non-computer scientists. The terminology of the technical areas of artificial intelligence, the whole broad spectrum, not just the latest and greatest developments, but the whole history of the field and all the different paradigms. And then the last third is on societal implications. And we have, I think, a great lineup of topics and speakers to treat you. So I'll now take a second to allow the course staff each of us to introduce ourselves. So Joydeep.
Hi, I'm Joydeep Biswas. I'm faculty in the computer science department. I work on robots, and in particular planning and perception for these robots. You might have seen some of our robots, including the wheeled robots and like the four-legged, the spot robot being deployed on Speedway. Some of the things that we're looking at is that how can these robots not be confused by construction on Speedway, for example. So those are my interests. Over to Don.
Hi, I'm Don Fussell. I am currently the chair of the Department of Computer Science and a researcher in a number of areas of systems, only some of which have recently been subsumed by AI, and others of which have been involved with the systems underpinnings that have made possible the current AI revolution that we're undergoing. So I'll be talking to you about some of the computing context for the AI that you're going to be learning about in this course.
And I'm Peter Stone. I'm a professor of computer science. I've been working in artificial intelligence for the last 30 years or so. through the sort of down periods where everyone knew that AI was sort of a field that had come and gone, through now these up periods where everybody's very excited about it again. I'm director of robotics on campus. I'm a founding member of Good Systems, which is our campus-wide initiative on AI for good. And one of the things I'm known for in the AI community is creating teams of robot soccer players, where our goal is by the year 2050 to have a team of humanoid robots that can beat the best World Cup team on a real soccer field. I'm now going to turn it over. You were very fortunate to have a fantastic teaching assistant, Zifan Chu, who's a PhD student in the computer science department.
Yeah, hello everyone. My name is Zifan Xu. I'm a TA for this course. I do research on AI, robotics, and reinforcement learning. I work with Professor Peter Stone, and unfortunately, I'm traveling for a conference, so I cannot say hello to everyone in person today. But I'm really excited about this new course, and feel free to reach out if you have any questions. Thank you.
Great, thank you, Zafan. So the remainder of today will be going on over the first reading. I know you didn't have as much time for this one as you will for others, and it was relatively long in terms of page numbers, but hopefully you found that it was relatively accessible and not wouldn't take too long to read. The readings for next week, I've verified, are significantly shorter in terms of page numbers, and we'll try to keep that manageable, and we'll also try to release them at least a week in advance. Gathering Strength, Gathering Storms is the report from the 100-year study on artificial intelligence, and I'm going to take a few minutes to describe to you what the 100-year study is, the AI100 as it's called. I've been deeply involved in it. And then tell you about the first study panel report, which happened in 2016, which I was the first author of, and then we'll go over the reading itself that you had for today. Even though this was published in 2021, almost exactly 2 years ago, I think on September 1st of 2021, I think it's still very, very current. There's been a lot of changes in the field. AI is very fast moving. But really, most of what's in this report is, I think, still very relevant to today. But you may have questions about that as we come to the Q&A period at the end of the session. So this AI100 is a privately funded effort that was launched in 2014. It's supposed to be a long-term investigation of AI and its influences with the idea of a body of experts issuing a report every 5 years, envisioning the potential future advances of AI and describing the technical and societal challenges and opportunities. The first report was in 2016, and I was the chair of that. So I'm going to take a few minutes. This was not your assigned reading. Instead, I'm going to take a few minutes to tell you about both the endowment and that first report. So the charge for the endowment of the AI100 is to support a longitudinal study of the influences of AI, centering on periodic studies of developmental trends and potential disruptions, and also proactive efforts. What can the AI community do to make sure that the effects of AI are more positive than negative? There was a sort of a meeting in Asilomar that I participated in back in 2008. Asilomar has sort of symbolic meeting. That's where genetic engineers had a conference once to talk about what they should do about genetic engineering from within the field. And so this was AI experts convening there, thinking about what should we do about the societal implications of artificial intelligence. But then that eventually turned into this 100-year study endowed by Eric Horvitz and Mary Horvitz. There is a standing committee. Until recently, I was chair of this standing committee, but I wasn't at the start. The standing committee invites a study panel that just comes together to write the report and then is disbanded. So I was actually the chair of that first study panel and then became chair of the standing committee that gave the charge for the second study panel. And then this continues on. And it's actually endowed beyond 100 years. So it's meant to carry on indefinitely. So back in 2015 or 2016, the charge that was given to the first study panel was to envision artificial intelligence and life in 2030. So to identify the possible advances of AI over 15 years, their potential influences on daily life, specifying scientific engineering and legal efforts that would be needed to realize these efforts, and to consider what could we do to shape societal good through AI. And there was a focusing device on that report, which was to focus on the implications of AI on large urban regions, a typical first world city, say. because that's where there's a lot of aspects of artificial intelligence that come together in multiple different sectors. The idea of these reports is to be able to speak to a general audience. So yes, AI researchers and practitioners, but also the general public, industry and policymakers. And this is one of the reasons that I selected this for your reading. A lot of effort went in to make sure that it would be very accessible and to be able to communicate to people who don't have any background in artificial intelligence necessarily, which is the theme of this course. These are the people who wrote the first panel. I'm not going to belabor that. You can find it online. But I think the structure of the first study panel report was very, very interesting. There's sort of a one-page executive summary, then a 5-page overview that sort of expands on that, and then the longer full body that expands on that. So there's sort of like a hierarchical or layered structure that allows you to dig in at different levels of detail. And the 8 areas of the study panel sort of thought a lot about what would be the areas of urban life where we would want to dig in and think about the progress over the last 15 years and the projections for 15 years into the future. And these are the 8 that were hit upon that sort of span AI's influence in hardware, with real robots, partnering with people, building trust, and societal futures, and also interpersonal interactions through entertainment. So the last thing I want to say about that first study panel report is that it does have a definition of artificial intelligence, and it's actually one of my favorite definitions of AI. It's actually worth noting that there is no generally accepted definition of artificial intelligence, which is a little awkward for a field. You may know there's not even a generally accepted definition of the word intelligence, right? So we're talking about artificial intelligence. So if you look at different AI textbooks, they'll all define AI slightly differently. And so the study panel of the 100-year study came up with this definition, which, like I say, I still stand behind as a very apt. It's a science and a set of computational technologies that are inspired by, but typically operate quite differently from, the ways people use their nervous systems and bodies to sense, learn, reason, and take action. So couple things to note about this. First of all, it's a set of computational technologies. It's not one thing. ChatGPT is an example. It's a neural network, but it's not the only aspect of artificial intelligence. There's many different technologies, many that have been developed over the years, and that's part of the goal of this course, is to introduce you and familiarize you with the whole set of computational technologies that comprise artificial intelligence. So there's some examples here: reinforcement learning, natural language processing, vision, planning, symbolic reasoning. These are terms that you'll become familiar with over the course of this semester. There's another definition of AI that is a little bit more tongue-in-cheek, but I think is also worth thinking about. Sometimes people talk about AI as the science of getting computers to do the things they can't do yet, which is a moving target. Right? There's things that are considered AI because computers can't do them, but then they start working, and then people say, "Oh, that's not AI. That's just search, or that's just that's just learning or understanding spoken language. We already know how to do that. Once it works, it's engineering." And just as an example, when I was a graduate student in artificial intelligence decades ago, it was a very current topic to try to get computers to understand spoken language well enough so that if you said your telephone number or credit card into the telephone, that a computer would be able to understand what those digits were. And now that's sort of taken as a given, right? That's a technology that works. You do that all the time. When you call your credit card company, you just say the digits. But there's a methodology, hidden Markov models, that went behind that, and people were trying to perfect it. It didn't work yet, so it was a topic for artificial intelligence. Nobody in AI now works on understanding digits from spoken language, although there are still challenges in understanding spoken language in like a crowded room and in a cocktail setting or things like that. Okay, so moving on, that was what I wanted to say about the 2016 report. It does actually come back as a part of the 2021 report, which I'll comment on later. But I'm now going to move on to your actual assigned reading, which was the Gathering Strength, Gathering Storms. And I'm going to sort of highlight some of the key points for the next 25 minutes or so, but I'm going to try to leave plenty of time for questions. So type them into the chat or have them ready if you're here in the studio. And I did say there was going to be different Instapolls sort of scattered throughout the time. And again, this is to make sure that you're here and paying attention. And they're also designed to make sure you did the reading. So here's an example of an Instapoll question that will test that you did the readings before coming to class. Okay, hopefully you've had time to answer that one. Again, not meant to be super difficult if you did the readings. It's just checking that you did, and so that's how that's part of the way we're going to evaluate that you complete the course requirements. So the study panel for the 2021 report, the chair was Michael Littman from Brown, and there's many people here. The composition is important because it's not just computer scientists, it's social scientists who focus on artificial intelligence, it's people from industry, it's people from academia, but it's people who have, they're insiders, and these are meant to be reports written by AI experts, AI insiders, to try to sort of combat some of the myths of artificial intelligence that sometimes come from the movies, from books, from popular press, and things like that. And as I've said, the goal is to have these reports come out every 5 years. This one that you read is interesting because it's the second in this century-long or longer series. And as we like to say on the standing committee, the first one was just sort of a stake in the ground. 1 point doesn't make a line, but 2 points do make a line. And so this second one was sort of in charge of sort of figuring out what this series of reports would look like over the years. And so the charge that was given to this study panel was to sort of do 4 things: to have some sort of reflections on the state of the field, to do a deep dive on a couple of questions, and those are the last questions at the end, what we call the workshop questions, and then to come up with a series of what we call standing questions, questions that could be answered every 5 years and might have their answers change over time or evolve over time, so that these reports, we can compare them. And so the next report would be in 2026. The plan is for many, if not all, of these same questions to be answered by the next study panel. And then possibly community voices. The reflections part is also interesting, the sort of reflections on the past report and what has changed since 2016. And so one of my favorite parts, and that I'll talk about at the end, is the annotations on the previous report that comment deeply on what the 2021 study panel thinks has changed since the 2016 study panel wrote its report. And that's easier to read online. We sent a note to that. If you printed out the PDF, it's a little more awkward to read. But if you view the interactive version online, if you haven't had time to do that, I really encourage you to. I'll come back to that at the end, as I said. Okay, so I am going to now just briefly go through the questions, the standing questions. The first one is one that I actually came up with, and that I think is, that I'm sort of very excited about. It's, what are some examples of pictures that reflect important progress in AI and its influences? And this sort of, I remember the first time I saw, a URL in an advertisement or on the side of an airplane, http:// something. When I was growing up, that didn't exist, and then all of a sudden it did exist, and they're everywhere. And artificial intelligence, advances in artificial intelligence are changing the world in ways that we can sort of capture through pictures. There's pictures that could be taken in 2021 that could not have been taken in 2016. And so that was sort of one of the charges that the standing committee came up with, or the study panel came up with, and they decided to sort of have one picture associated with each of the other standing questions. And so those will be pictured on the coming slides, and you saw them as you read. So the second question was what are the most important advances in AI over the past recent years? This was a couple years ago, but I think very, very current. Generative adversarial networks. This was before ChatGPT had been launched to the world. So that term didn't exist yet in 2021. But there were already the technologies that are behind it and other GPT models, GPT-1, GPT-2, they were around. And it was very clear to insiders that they were changing the world, even though the general public yet had not come across them. And these are the result of transformer language models. There were also some, they had called out robot deliveries during the pandemic as an influence of artificial intelligence, and also the expansion of AI systems into hospitals. So these were the things identified by the study panel. And this picture here was an example of the output of a generative AI model, something one called DALL-E that combines language and images. So a person could type stained glass window of a blue strawberry, and it would come up with a whole bunch of different examples that didn't exist in the real world, but generates them. And how that works, the technology behind that will be one of the topics of your classes later in the semester. Another standing questions: what are the most inspiring open grand challenge problems? So this was the one you had to have read to be able to answer the last Instapoll question. You know, so there is the Robot Soccer World Cup. That's something that I'm a big part of, and I already said the goal of, you know, for 2050. But there's, you know, sort of technical challenges within the field trying to get artificial intelligence to generalize well. So what do we mean by that? That means, like, you know, if you have a program that can beat the world champion at chess, or, you know, can you make it so that the lessons it's learned apply to other things as well, you know, to checkers or Go or things like that. Or if you train an autonomous car and it can drive, you know, in a city, can it then also generalize so that it can drive well in a suburb or things like that? So that's what we mean by generalizing, moving out of where it was, you know, sort of trained or developed. Another challenge is understanding causal factors. So, you know, people are very good at saying, I'm wet because it's raining outside, or you know, that person is carrying an umbrella because it's raining outside. What causes another thing to happen? Right now, most AI systems are better at correlations, what we say. They, you know, things that happen at the same time, but you don't know which one caused the other. Is the person carrying the umbrella causing it to rain? Or is the fact that it's raining causing the person to carry the umbrella? They happen at the same time. This causal reasoning is something that's very natural to people, but it's sort of still a challenge for artificial intelligence systems. And then also being able to pick up cultural norms, to be social, to be able to you know, again, very natural to people, but this is still a big open challenge for artificial intelligence systems. And in all of these, there is some work in the field, but they're certainly not solved. The next standing question that the study panel looked at was, how much have we progressed in understanding the key mysteries of human intelligence, sort of the realm of neuroscience and psychology? The answer is, you know, there's still a long way to go, right? We have, and you know, these in many ways, I mean, I got into the field of artificial intelligence because I wanted to understand the nature of intelligence. And you know, at the time, I felt like the progress in neuroscience was too low level. People were working on sort of the chemistry of how you know, axons and dendrites and synapses worked, but that didn't really tell me anything about what happens in a person's brain when, you know, you tell me your name and I remember it. And then similarly, psychology was sort of at the other end, sort of very high level, looking at explaining behaviors that were observed in people, but again, not explaining what were the mechanisms of intelligence. And so I went into, you know, into artificial intelligence, the lens through computer science, because I felt like, you know, that was, for me, at the time, the best way to get at the nature of intelligence. That may not be true anymore. I think, you know, it's one of the ways, certainly, but there's been a lot of advances in both neuroscience and psychology, and these are very exciting areas that I think, together with artificial intelligence, are helping us make progress on understanding just the nature of intelligence in general. But it's still, I think it's, you know, it is sort of the frontier. I sometimes say that you know, and other colleagues of mine also say that the three big scientific questions of our day are, you know, how did the universe start? How did life on Earth start? And what's the nature of intelligence? And so, you know, there's still just a lot of mysteries there. In the report, they talk about studying network effects, that intelligence doesn't just arise as an individual, but there's interaction between regions of the brain and also between multiple intelligent entities. Many, you know, people form societies, robots or software agents can also form collectives that can, you know, exhibit more intelligence than a single entity. The fifth standing question was, what are the prospects for more general artificial intelligence? So there's a term that has sort of been popularized. I'm not really a fan of it. People talk about AGI, or artificial general intelligence. Really, the whole field of AI, artificial intelligence, has always been trying to strive for general intelligence. So there's really not, a differentiation between, sort of AI and AGI. To me, it's all artificial intelligence. There is, sort of words, people talk about whether there's narrow artificial intelligence that's good at one thing versus more broad. But again, it's more of a continuum. There's not just sort of, fully narrow and fully broad. It's more of a spectrum. And the whole field has really been, always working towards this, sort of dream of creating a fully intelligent artificial agent as a way of understanding intelligence, and then, and as from the science perspective, and as a way of getting machines to do intelligent things from an engineering perspective. But this is maybe a controversial statement that the study panel wrote, was that human-level AI systems feel further away than they did 5 years ago. I do identify with that myself. There's been progress, certainly, but and there's amazing capabilities of the latest AI technologies, and yet, as we look at them and sort of dissect them, we also find huge gulfs between what people's brains can do and what these systems can do. And there's always been aspects, for a long time, there's been aspects of intelligence that machines are better at than people. For instance, I wouldn't want to get into an arithmetic competition with a calculator. But there's just aspects of human intelligence that are just amazing and unexplained from a neuroscience and psychology perspective, and unreplicated still in AI. And it still feels like there's a real long way to go to close that gulf. But nonetheless, there are, they identify some technologies that are showing promise in terms of generality, and those are listed here and called out in the report. The sixth question was how has public sentiment towards AI evolved, and how should we inform and educate the public? This course is in some sense a response to that question. It's that we do think that and the study panel thought that it's really important now to help everybody become literate in artificial intelligence. But it's also important to recognize that media coverage tends to exaggerate the positives and both the positives and the negatives of AI. And I think that's also true of entertainment, of movies and books. You tend to see either fully utopian societies like the Jetsons, where Rosie the robot. Some of you may have seen this. I'm dating myself by making a Jetsons reference, but it's sort of an old TV show where the world is perfect and everybody has leisure because of the robots. And then there's the more dystopian, where robots destroy the world. And but there are, so there's a lot of exaggerations, and the reality is more middle ground. But there also are real issues to be concerned about. It's not that that everything is all positive with technological development. There are real things about bias and lack of transparency and accountability. These are themes that will come up at the end of the course, that are important for us to engage with. And that the conclusion was that researchers and practitioners need to engage in conversations to keep this discussion grounded and productive. But an important point here is that this isn't unique to artificial intelligence. This is true of almost any disruptive technology. And I think if you think of things like automobiles, airplanes, and telephones, internet, social media, there's positives that really enhance our lives, and there's negatives that we have to sort of guard against. And it's the job of society and to sort of figure out how to steer towards the more positive implications. And again, a big theme of this course. how I should say, and also in terms of informing and educating the public, the computer science department here has also launched an online master's in AI that's also playing that role. So this course is sort of AI literacy for everybody, and then we're also trying to help educate another, a much larger group of people who are ready to go into the technical workforce, not just in technology companies, but also into government and policy, who are educated and literate in the details of artificial intelligence. And this relates to standing question 7, how should governments act to ensure AI is developed and used responsibly? This has been very active, even more so. It's accelerated since 2021 when this was written. Countries are creating AI initiatives to maximize the benefits and minimize the harms. The sophistication of policymakers has gone up significantly in terms of AI literacy. Still with some, of course, not everybody, and with some gaps, but I think it's certainly much better than it was in the past. But the conclusion in the report was governments need evidence-based processes to innovate and keep pace with AI because things are continuing to move forwards. Standing question 8 was more the economics question. What should the role of academia, this is the academia and industry one. What should be the roles of academia and industry in the development and deployment of AI technologies and the study of the impacts of AI? And this is actually very, it's an interesting moment for those of us in artificial intelligence where there are some of the latest and greatest technologies that are being created by industry and only sort of available to, only industry has the resources to create them. To train GPT-4 or Lambda, you have to be a Google or a Meta. Governments don't even have the resources to do this. Certainly individual academic departments don't. This is sort of a flip from business as usual. It used to be that the innovations came and the newest technologies and newest developments came exclusively from academia and then got taken up by industry. Maybe exclusively is too hard a word, but now there's a lot more partnership. I'd say that the resources to train these models is in industry, but there's a lot of crossover, and this graphic is sort of the number of papers that are published by people with industry affiliations, but many of them are collaborative. Where there's academics and people in industry working together. But there is a concern that industry researchers are not necessarily driven by the needs of society. And so there's questions about what to study and how to disseminate that knowledge. The standing committee, or the study panel, thought that was a very important issue to keep an eye on, and I think that remains very true. What are the most promising opportunities for AI? They called out, I think the biggest one being that both for practical and intellectual reasons, they think that the field should focus on ways that AI technology can be better integrated to work with people effectively. So sort of the human AI interface. It's not, tasks aren't going to be done just by artificial intelligence or just by people, but they're going to be done by AI technologies working with people. And so, how do we make that happen better so that a system that's a hybrid of an AI technology and a person makes better decisions than either one of them alone? And then the last standing question was, what are the most pressing dangers of AI? And so we've all become familiar with many of these through the press recently, but the ones that they called out as most pressing are helping to turbocharge the spread of disinformation, and that that AI systems are often designed to cater to the majority, presenting significant risks to members of underrepresented groups if they're not sort of used responsibly and carefully. And so this is the sort of the famous picture of a sort of a blurred version of President Obama that was given to an AI system to try to turn into a high fidelity version of the picture, and they turned him into looking like a white male. And so this was a famous example of where sort of there's bias encoded in these models. So this was the last standing question. And so next I'm going to show an Instapoll question that's designed to test to make sure that you're paying attention at the lecture. Okay, again, these aren't meant to be trick questions. These aren't things you're going to need to study for. You just need to do the readings. You need to pay attention in the lecture, and you're going to do fine in this course. Oh, that wasn't the last standing question. There's a couple more, and then the workshop questions. So standing question 11 was, how has AI impacted socioeconomic relationships? We'll have a question on a topic later in the course on AI and work, the future of work. You know, they talk about the question of robots stealing our jobs, generating a lot of concern, and they did say it's a possibility that should be watched, but it's not really happening yet. That to date, the rises in inequality and unemployment don't appear to be due to the spread of AI technology. That and you know, the economists were weighing in on this, you know, saying that there's you know, even employment as a fraction of population reached a 20-year high right before this report came out. One of the things that AI experts have been saying is that, you know, it's less likely for most jobs. It's not that artificial intelligence technologies are going to be stealing jobs from people. It's that people who are literate at artificial intelligence are going to be stealing jobs from people who aren't. And that's the point of this course, is to help you be one of those people who is literate in artificial intelligence. People who know how to use the tools, who know what the technology is. And that's because it is going to change. It's a disruptive technology. It's going to change sort of the way things work in almost every sector. You know, it's probably as more often than not going to be stealing jobs or replacing jobs, but changing and augmenting them. That's not to say that there aren't any jobs that are going to disappear. Every technology, every disruptive technology does sort of you know, change what jobs are available, but often more new jobs are created than old jobs are removed, and you know, that may very well be the case with AI technologies as well. And then this is the last standing question. Does it appear that building in how we think works as an engineering strategy in the long run? This is a question that's pretty subtle, and it is one that you'll get more of a handle on in the next few weeks. The original AI paradigm was sort of planning. That's what you'll talk about we'll talk about in next week's lecture. Was more of a build in how we think kind of thing. Can we program computers to do the things that people do, but build in those mechanisms? And then the pendulum sort of swung all the way in the direction of, let's not build in anything. Let's just try to let machines learn from data, and let's not bias them by our own impressions of the way the human brain works or the way intelligence works. And so a lot of the latest technologies are self-supervised. They're learning from data. But the study panel thought that they were sort of seeing the beginning of the end of that trend and moving more towards hybrid designs. And that's something that I think is going to become increasingly important over the coming years, is how do we take the various AI paradigms that have been created over the years and merge them, not just use a ChatGPT or a Lambda or a Bard, but how do we mix that with the things you're going to learn over the next couple classes, reasoning under uncertainty and planning. And then finally, there were the deep dive questions. There were a couple of workshops that happened before the study panel wrote their report. One on prediction in practice. So, you know, how are AI-driven predictions made in high-stakes public context, and what social, organizational, and practical considerations should policymakers consider in their implementation in governments? A group of experts came together and wrote a mini report on that, and then it was reflected in this report, deciding that it's important to design AI solutions to real-world problems by working closely with the stakeholders. Don't just try to, you know, sort of say, here's an AI system, now go use it. Involve the people who are going to use it as you're designing it. And also, if a problem is complex enough that we need AI to solve it, then it's complex enough probably that AI can't solve it alone. That it's going to need to be, again, AI and people. That theme came through here again. And then finally, a deep dive question on how artificial intelligence is changing care. The pressing challenges and significant opportunities in the use of AI to provide physical and emotional care to people in need. And the conclusion here was that caregiving is an intimate and human act, that there's need for automated support. Replacing human care relationships could undermine our humanity in tangible ways, and this is a very tricky issue to think about. So don't just think about, oh, let's do the job of caregivers with robots. There would be something very real lost there, and that was one of the conclusions. And then finally, again, sort of my favorite, one of my favorite aspects of the report is that this 2021 study panel went back and annotated the 2016 report with comments about what they think has changed, what they think is the same. I really encourage you to read those carefully if you haven't already, most conveniently in the interactive version online. So that's what I wanted to say. I'm going to move to about 10 minutes for questions. The summary of your reading of the 2021 AI100 report is that AI has made remarkable progress over recent years. It is a really exciting time to be in the field. There have been leaps forward in language and image processing tasks, applications in healthcare and self-driving cars, as you can see if you're out in Austin these days. But it's still far short of the field's founding aspirations of creating really, truly general artificial intelligence systems. There was a sense that we are really at an inflection point for the field, that it's urgent to not just think about the way AI can help the world, of which there are many, but that we have to balance those against the downside risks. And things like automating decisions at scale, bias, in a number of ways, and they talk about social sciences needing to be part of the broader AI conversation. That's sort of the theme of good systems here on campus, and that ongoing engagement is essential. There's themes of the government recognizing the importance of AI and starting to move and needing to move quickly, and keeping people informed education-wise. Again, one of our goals with this course. And then there's lessons for the AI research community, a call to action, to learn to share findings in informative and actionable ways, avoid the hype, try to be as realistic as possible, discussing both the upsides and the dangers, incorporate AI into community-wide systems, and try to make the goal to be to empower people, not replace or devalue people, but empower them. So again, I hope you found this reading enjoyable and accessible. We'll be happy to answer questions in the online forum, but now we'll take a few minutes to answer your questions about anything that I've said in the last few minutes.
So, the first question we have from the audience, Peter, is do you think that AI can be used in biomedical engineering?
So I would probably say yes to no matter what question, what the answer, the last two words of that question were. But I would correct the question a little bit. Can AI be used? Can AI I try to say not just AI as a thing, but as a collective. So can AI technologies be used in biomedical engineering? I think certainly advances like you may have heard of AlphaFold, which does sort of predicts protein folding and things like that, is one AI technology, was developed by DeepMind. I think is very relevant to that topic. But I think like I say, for almost every area, there are AI technologies, AI tools that can be put to use.
Okay.
There's a question in the room, yeah.
So I actually don't even know if this is fair or not, so that might be the first part of the question, but I feel like some AI models have like a reputation for like giving good answers, but not providing as much insight or like knowledge of the process itself that comes from like trying to solve that problem more functionally. And so beyond one, asking if that's fair, I also was wondering like, if it is a real concern, what are the sort of things that people are thinking about to address that? And also, as AI technologies move farther along the path to being generalized, how much more essential does that become when there are, so many, it becomes so much harder to untangle all of the components of what is going on?
Yeah, that's a fantastic question. I'm going to assume that people online can hear the audience. So I'm not going to repeat the question, but someone correct me if I'm mistaken about that. Yeah, so the area, the sub-area of artificial intelligence that focuses on that is called explainable AI, or explainable artificial intelligence. And it is a fair question. It's a very real one. Do we just care whether a system tells us the right answer, or do we care if it can explain to us why it's the right answer. So if I'm a doctor, or say I'm a surgeon, and I want to ask an AI system, is this, here's a patient, should I do surgery on this patient, or should I send them to physical therapy or some other course of action? An AI system might just say, well, based on all the past data, you should do surgery. But then, the surgeon wants to know why and be able to explain it to the patient and figure out whether they can trust the system. And so that is part of the reason that people are looking at these more hybrid methods. So there are AI technologies that can just give you the answer, and then there's more symbolic methods, so people call it neurosymbolic reasoning, where you have the neural network model that can tell you the answer, and then a symbolic component that can sort of convert that into understandable terms. There are also AI technologies that you'll learn about that are understandable to begin with, or explainable to begin with. And so, yeah, I think this is important. It depends on the application, how important it is that it's explainable. I probably don't need an autonomous car to explain to me, every fraction of a second why it pressed the brakes or why it accelerated, but maybe I do want it to explain to me why it decided to take the side road rather than the highway. And so, these are kinds of interface questions and also technology questions that are very relevant, and they're difficult. So it's a great question.
Can you expand on the importance of social sciences and humanities in AI?
Yeah, that's a great question as well. So, I mean, it comes down to this, artificial intelligence technologies are impacting the world, that people are using them. This interplay of AI and people is important. And so, one of the projects I'm involved in, and Joydeep is involved in as well, is one called Living and Working with Robots. That's one of the Good Systems projects. And part of that project is about creating robots that can inhabit our society, that can, that have the capability of navigating through a crowded street and to get from one building into another and do deliveries for us. But another part of that is, will people accept them, or will people be scared of them? Will people see them as a threat? There was an example of pizza delivery robots in Austin that made the news a year ago that ended up using the bike lanes, and then all the bicyclists complained, right? And so, and with good reason. And so, it's not just about the technology, it's about what are going to be the impacts on people, on society, how are people going to interface and react with them. So, I think the perspective that the humanities and social sciences bring is now essential as AI becomes not just about the technology, but as it gets out there into the world and affects society at large.
Okay. Can AI teach us anything about emergent properties of the human brain?
Yeah, I don't know the answer to. That's a really good question. Like I say, there's interplays between artificial intelligence and neuroscience. People definitely do use machine learning models to interrogate and ask questions about how biological brains work, starting not just with human brains, but also fly brains, Drosophila, or monkey brains, or mouse brains. People build models of them and then say, well, what happens if I change this architecture to be more one way or another in an artificial system, and then does that reflect the same things that we see in biology? There have been some examples of lessons learned from neuroscience that originated through AI models and vice versa. But it's certainly not the case that just because it happens in an AI system, it will also happen that way in a brain, in a biological brain, nor vice versa. So I think, yeah, probably the answer is yes, there are things to learn, but that doesn't mean that it's going to the details are the devil's in the details there.
Why did human-level AI systems feel closer 5 years ago? Is this because learning has taught us more about what we don't know?
Yeah, that's the point. That I think the same effect. The joke is when a teenage child goes to college, they come back thinking that you're smarter. Same thing is the more we see that what the systems as they learn, we can identify the aspects that are difficult, and they become more and more difficult as we get sort of closer to the boundaries. So yes.
All right.
So I think with that, we do need to wrap up. Thank you all for your attention and for the questions. Just before we close, and the way the classes are going to work every time, there's going to be a different lecturer each time to talk about the readings. And one of the three of us will always be here to MC, to introduce the speaker, and to field the questions. But I'm now going to turn it over to Professor Biswas, who is your lecturer a week from today, to give a little bit of a preview of what you're going to read and what you'll hear about over the next week.
Sure. Thanks, Peter. So we've already assigned the background reading material for this, but next week what I hope to cover are some of these interesting questions of, first of all, what is planning? What's so hard about it? And how can you use planning to teach a computer to play to win at chess? And interestingly, how do you move a grand piano into an apartment? So if you're interested in finding out the answers to these questions, please join us next week.
And just in case you're worried about it, the readings for next week are considerably shorter than the one for this week.